In this problem, we find dy dx by implicit differentiation. And so the way we do this is we copy down the problem. And what we're going to do is we're going to apply the derivative operator, ddx, to both sides of this equation. Now, I'm going to go ahead and then find the derivative of x squared, and then the derivative of each of these terms, xy, and then y squared. So I take the derivative of each of these. It's called linearity that allows me to do that. Okay, of the derivative operator. So this is the derivative with respect to x. So the derivative with respect to x squared, the derivative with respect to x of x squared is 2x. The 4 I'll leave alone, that's a constant. And now I look at x times y. So I'm going to use for this the product rule. And I have x, and I'll take that derivative. The prime means with respect to y, to x. And then I have times y plus x, and then y prime, which means the derivative of y with respect to x. Then I come to the derivative of y squared. The derivative of y squared with respect to y is 2y. And then I'll multiply by dy dx, or you can write y prime, which means the derivative of y with respect to x. So that's what you do with implicit differentiation. For this guy right here, you could think of this, but maybe it's not such a good idea to do this, but you could think of this as saying, okay, here's y as a function of x, and I'm taking the derivative. If I write it like that way, which is not really the most common notation for this part of the book, but still, I could write it that way, then we can really see that there's a chain rule taking place here. So I have the derivative of y of x squared, so the chain rule says I take the derivative of the outside. And then I multiply by the derivative of what's inside. It's exactly what I wrote down here below, except I didn't write y of x, I just wrote y. But that's what we're doing here. You don't want to write that out every time. What you want to think is that when you come to y squared and you take the derivative with respect to x, you take the derivative of y squared with respect to y, which is 2y, and then you just throw at the end y prime. So let's just continue on this. You have 2x minus 4. The derivative of x with respect to x is 1. So that's times y. And then the derivative of y with respect to y is 1, but then times y prime, which is the same as just take away those parentheses and just write y prime. And then you have 2y, y prime equals 0. And really, the hardest part, and often I think, is the next step in this problem, which is we want to solve for y prime. Now, as I was talking, notice I multiplied through by -4, so I'm using the distributive property, and I want to solve for y prime, which is the same thing as dy dx for this problem. And so first, I'll use addition and subtraction to move everything that does not have y prime to the right-hand side, and everything that has y prime I'll keep on the left. So the 2x, I'll subtract both sides by 2x, and I'll bring that to the left. It's negative 2x. I add 4y to both sides. So everything on the right doesn't have a y prime, on the left it does. And then I'll factor out y prime. And then I almost have y prime by itself. It's y prime times an expression there. And what I'll do is I'll divide. I'll divide both sides by -4x plus 2y. And I see that I have a common factor of 2 all throughout, which may have been easier to deal with earlier, where I have 2x, I have 4, 2. I could have divided by everything by 2 earlier. Maybe that would have saved a little bit of trouble, but okay, but that's still, I think it's fine. So I'll factor out 2 in the numerator and 2 in the denominator. So therefore I have y prime, or which is dy dx, is equal to negative x plus 2y over negative 2x plus y. Now, if we multiply the numerator and denominator by negative 1, you'll get x minus 2y divided by 2x minus y. I'm not saying that that's any better. It's simply that's maybe the answer you got, and it has to do with how you move things around doing the solving for y prime. But that's when you multiply the numerator and denominator both by negative 1. And actually that does look a little better. So maybe I'll do that. Just write that down there. So that's just, how do I get that, is I multiply by negative 1 over negative 1. So I'll say that that is actually my answer, because I think it just looks a little bit better, but not necessarily. Okay, and that solves this problem.